Okay, this is the mid-chapter 3 practice test. This is what we've got. So I'll look at some problems that you might see on the test. The first one is if the limit as f of x approaches equals as x approaches 0 from the left is negative infinity and as x approaches 0 from the right is positive infinity, f prime fails to exist because the graph has a what? So we have to make sure we know our definitions. And remember, if one side is negative infinity, the other side is positive infinity, we have a cusp. So that was pretty just a straightforward, make sure you understand. And then if x approaches one side 4 and the other side is 3, remember if both limits exist, but they're different, but they do exist, as identifiable numbers, then we have a corner. So I think that's pretty much just have to understand those definitions. Now if the limit equals infinity on one side and 1 on the other side, it doesn't really matter. If it equals infinity, that's going to be an infinite discontinuity. Any kind of discontinuity is going to cause an issue, so that would be a discontinuity. Discontinuity. And if we have as x approaches 0 from the left and as x approaches 0 from the right have infinity, or if they were both negative infinity, remember that, then we're going to have a vertical tangent. So those are the 4 things we talked about. Tangent. So I think that's reasonable. That's a reasonable question. We did a lot more work with that than those and proved them, but let's just do this for now. Okay, and then over here we have dy dx. So we want to find the first derivative and the second derivative. So I'll just write this over here. So y equals, I guess I'll put it in black, y equals 4x to the 5th minus 5x to the 3rd minus 7x squared plus 4x plus 20. And if I take the first derivative y prime, that will also be dy dx. Okay, that's the first derivative. Some people have trouble with this notation, so remember, dy dx is the same thing as y prime. I know we use y prime a lot, but it can also be dy dx. Let me get this straight so it's lined up here. So if I take the derivative, dy dx, y prime, the same thing, is going to be 5 times 4 is 20x to the 4th. 3 times 5 is 15, x squared minus 14x plus 4. So that's our first derivative. 20x to the 4th minus 15x squared minus 14x plus 4. And then the second derivative, and that's y double prime, and that, remember, that's the same thing as d, okay, d squared y dx squared. So those are the same things, so don't get fouled up on that. That's just going to be the second derivative of the derivative of the first derivative, the second derivative of that. And that's going to be 4 times 20 is 80, x to the 3rd minus 30, x minus 14. Okay? So that's what we have there. So that was number 5, because the first 4 were those other ones. Okay, and then number 6, we have these numerical derivatives, and we had our values. And the first thing, 6a, we want to find the derivative with respect to x of 6 times uv. So that's going to be 6 times, and then we're just going to use the product rule. First times the derivative of the second, plus the second times the derivative of the first. And that was 6, and those values were given as 4 and 3. If you look those up, we were given the u prime of 2, or the u of 2 is 4, the v of 2 is negative 9, the u prime of 2 is 5, and the v prime of 2 is 3. So we just want to evaluate that at x equals 2. So those end up being 4 times 3 plus negative 9 times 5. That was equal to 6, and 4 times 3 is 12, and negative 45. And that was equal to 6 times negative 33, And that equals, and a positive times a negative is a negative. 6 times 3 is 18, carry 1, 18, 19, 198. So you better be able to multiply a little bit because you won't have a calculator on this. All right. And letter B, just the quotient rule, straight out quotient rule. The derivative with respect to x of u over v, which is low d high, low d high less high u, d low, the derivative of v is v prime, denominator squared below. So we have our values, so all you have to do is substitute your values into these. We've done plenty of these, so this is no problem. So this ended up being v at 2 was negative 9, so we have negative 9 times 5 minus 4 times 3 all over v squared. V at 2, remember v at 2 was negative 9, so I've got negative 9 squared. So you make that substitution, and you have negative 45 and negative 12 all over 9 squared. Negative 9 squared is 81. So that's negative 57 all over 81. And you could reduce that. You could leave it like that. That's all right. But that's going to be negative 19 over 27. So that was up to 6. I'm sorry. You can see all that stuff. So those are your calculations. So you can check your calculations. You should be able to do those. Those are just like, I think, number 23 and 24 on homework or on section 3.3. So that shouldn't be a problem. Okay. So those are the first 6